Okay, so we are in Introduction to Statistical Learning. We're on Chapter 7, and we're going to lump together questions 11 and 12 here. These are the end of the chapter. And so what we're going to do here is explore a method called backfitting, which the book makes brief mention to in terms of fitting generalized additive models here. Generally software will do this for you, but it is kind of interesting to see how it works. This is this is a brief description of what it's doing. So if we had multiple linear regression, but we only had software that could take one variable at a time, how might we overcome that? And we can do that with backfitting in this case. Okay, so we're just going to walk through this example here. Okay. The first thing that we're going to do is generate a response y and two predictors, x1 and x2, with 100 samples. Okay, and then we're going to initialize beta 1 to take on some value here, and I'm just putting it at 0. Okay, so we have 100 samples. I am arbitrarily setting beta naught to 3. Which is going to be one of our coefficients. And then I have my variable x1. Okay, and then I'm calling beta 1, which is the coefficient for x1. I'm just arbitrarily setting it to 2. And then similarly for x2. And then I have an error term here for y, right? And then I'm just creating y out of my beta naught, my beta 1, x1, beta 2, x2, and my epsilon here. Okay, and then in order to get the algorithm going, you'll see why in a second, but I need to start with some initial values here. And so again, I'm starting beta 1 hat to a value of my choice. I'm just setting it to 0. And we're going to iterate starting from beta 1 hat equals 0, and we're going to update each of the coefficients one at a time until we converge. In other words, these updates stop resulting in a difference. Okay. And hopefully the place where they stop making a difference converges to the values that we set for beta 1, beta 2, and beta naught. Okay. All right, so now the next part, for parts C and D, we're going to fit this model right here, and then part D is then to fit this model given what we find in that model. So notice that all that we've done here is we had the beta 1 x1 term. We just moved it over to the other side, and that's how we found that. Okay, and then that will help us get an estimate for beta 1, and then that will help give us estimates for the beta coefficients, and then we will use those estimates in the next part here. But now moving beta 2 over, and we just kind of keep cycling through the coefficients here. Okay, so the question actually gives us the code to do this, so I've just kind of copied and pasted that code here for that part. Okay, and for part D, it also gives us the code. Okay, so that's all I'm doing. I've made some modifications here with what I'm naming the different coefficients, estimates of the coefficients, but that's fine. We don't need to worry too much about that. I should probably run this code as we go along here. Okay, so now after just one iteration here, let's just see what happens to our estimates for beta 1 hat. Let's just see what that is. So it's roughly 2. Trying to see, so beta 1. We actually set that 1 to 2, so it's fairly close. What about for beta naught? Beta naught hat 3.2, and I think that we set it to 3. Okay, so after one iteration, it's reasonably close here. So okay, so anyway, let me clear that. Okay. So now we're going to take what we've just done, and we're going to loop through it, 1,000 times, getting estimates for each of the coefficients, beta naught, beta 1, beta 2. And then we're going to plot the iterative values here, and then compare it to what we know the actual values are. Okay. We'll also use multiple linear regression, kind of what we're familiar with, and compare the estimates from multiple linear regression to this backfitting. Okay. And then we'll kind of make a qualitative judgment as to how many iterations it takes to get a good estimate for using backfitting. All right. So so I won't walk through all of this code here, and you can walk through it for yourself. But roughly what we have, I'm setting the number of iterations here, and then I am making empty vectors for my estimates for my iterative values of the beta coefficients, and then I am setting them equal to some initial value. And now I run the for loop, which is basically just the code that we already ran, okay, with some minor modifications. For instance, I am here getting an estimate for beta naught instead of just beta 1 for beta 1 and beta naught, as opposed to just one or the other. Okay, and so anyway, but we're going to loop through that, and each time it gets an estimate, okay, each time it gets an estimate, it's going to fill in our empty vectors for the betas, and so then we'll have every iterative value for the betas. Okay. Now I also have my multiple linear regression here, and so here I'm just, so that's the multiple linear regression, and then I'm just pulling out the individual coefficients, okay, given the not backfitting, but the multiple linear regression, and then I'm just going to plot it all right here, and so you can look at how the plot gets constructed here. But let's just run this. Let me pause it while it runs. Okay, it actually runs pretty quickly, and so let's kind of walk through these a little bit here. Okay, so first we have the beta naught, the intercept. Okay, so the true value is the shaded region right here. Okay, and then the multiple linear regression value is the dotted line, and then the iterative values are the solid line, right? And so almost immediately the solid line falls on top of the multiple linear regression line. And in this case, when we generated this particular set of data, it was a little bit off of what we know the actual value to be. Again, why do we know that's the actual value? Because we set beta naught to be 3. So just when we generated this particular set of data, that was the best estimate that we got. Okay. So similarly for beta 1, so the true value, the one that we set, is this kind of lighter shaded region. Okay. And then we have the multiple linear regression in the dotted line, and then we have the backfitting algorithm as the solid red line. And so we start here, right, at one iteration, okay, and already it looks like by the second iteration, it more or less jumps right on top of the multiple linear regression line. Okay, so that's interesting. And then we have for beta 2, same things here. So I won't repeat all of that, but you see very quickly in this example, given these starting values, etc., the backfitting algorithm, even though we ran it for 1,000, right? I only set the x-axis here to like just a few, because it very quickly gets on track. That's not guaranteed. Depending on the complexity of the model, etc., that may or may not happen. So anyway, so there we are. Now the reason I'm tacking question 12 onto this is we're going to fit the backfitting algorithm, but now using 100 different predictors here. Okay, and so we're going to show that we can approximate the multiple linear regression coefficients by doing this backfitting procedure. But now we have, instead of 2 covariates, we have 100. Okay, and again, we're supposed to look at how many backfitting iterations are required in order to obtain a quote good approximation. Okay, and we'll create a plot. Okay, so again, I'm going to generate some data. So I'm going to have 1,000 data points with 100 parameters. Okay, and so I have I'm going to artificially generate my beta values. Okay, my coefficients for each of the predictors. Okay, right here. Notice I don't have an intercept. So So we're going to run this without an intercept, all right? Right, because each beta is associated with an X term, okay? And I have, right, I hope that makes sense, okay? And so I'm going to create a matrix here, okay, that is n by p, okay? So in other words, I have 1,000 observations. Each observation has, 100 things that were, measured. So think about it as 100 people, and we measured, or 1,000 people, and we measured 100 blood markers, or something like that, okay? And then we have, and then to each individual, we also have an R norm, or we have an epsilon term, okay? And then to create my Y, I just multiply the X times the betas. If you're not familiar with this, this is matrix multiplication, okay? This just multiplies, for each row in my data, it multiplies that row times the corresponding beta coefficient. Then I'm adding my error term here, my epsilon term here. Okay. Okay, so now I am going to first run backfitting. Okay, so I'm just setting the iterations to 25. I'm doing this because I know 25 will be sufficient, and because because we have so much data here, it will take a while to run, and so just to decrease the amount of runtime, that's what I'm doing. So just 25 iterations. Okay. And I'm going to, with each iteration, I am going to fill up this matrix that I've created. I'm going to fill up this matrix that I'm creating. That will have one row for every iteration plus my initial values, and for each column, right? So in other words, each row of this big matrix will be the values of the betas for that particular iteration, okay? And so now for each iteration, I am going to run. I'm going to run a for loop, and in that for loop is another for loop, wherein I fit a regression that does not contain, right? Does not contain the Beath predictor. Okay, so I hope that makes sense. So if you look at, this expression right here, that just simply corresponds to what we did up here, where we got rid of, on this side, where we got rid of one of the predictors. Okay. And then with that, we fit our what do I want to say here? we then run linear regression on the one thing that was held out. Okay, so I hope that makes sense. Sometimes it's just easier to read the code rather than to verbally say what's going on here. Okay, so I'm running that, and it takes a second. Okay, so it's done. So just to kind of show you what this looks like here, if we look at the backfit betas here, we can just kind of see what has happened here, right? So here's the first iteration, right, where we preset all the values to be 0. So there's one column for each of the P predictors. Okay, and then after the first iteration, these were the values for the P predictors, and then the second iteration was this, and so on and so forth, right? Until we get down here, and you can see that as we go down, the change that is occurring, from here to here, decreases and maybe becomes nothing at all in some cases. Okay, so that's what we have. Let me just get rid of that. Okay, and so now again, we also want the multiple regression here. So we're going to run multiple linear regression. And now we need to find some way of comparing the backfit values to the multivariable linear regression. Okay, and so I'm going to create a vector here called squared error, right? And we're going to fill this vector up. And so for each iteration, I'm going to take all of the coefficients from the multivariate regression minus minus the row, for each iteration of the backfit from the backfitting algorithm. Okay, so I'm going to take that difference and square it, and then I'm going to sum all of that. Okay, so that's going to be my error for each iteration. And then I plot that, and you see very, very quickly the error more or less bottoms out by 4 or 5 iterations, something like that. So very quickly. So very quickly, this backfitting algorithm, even though we ran it for 25, it very quickly just bottoms out. So and lines up with the multivariate estimates. So anyway, that is chapter 7 concluded, and so that means that we will be moving on to chapter 8, and I believe that chapter 8, take a quick look here. So chapter 8 is tree-based methods, and there's some cool stuff there. So, all right, we will see you then.